we're going to finish day 23 notes. And if you'll remember, we had done a lot of talking about absolute and relative extrema. Remember, a relative extrema is a hill or a valley, right? A relative maximum is a hill. Remember, the definition of a relative maximum is where your curve changes from maximum, increasing to decreasing. A relative minimum, your curve changes from decreasing to increasing. An absolute maximum means absolutely the highest point on your graph. Absolute minimum, the absolute lowest point on your graph. We talked about the terms concave up and concave down. Concave up catches water. Concave down sheds water. And then we talked just a little bit, the point where your curve changes, concavity, is called the point of inflection, and that's where we're going to pick up. So define point of inflection, the point where your graph changes concavity. There are going to be some places here where I'm going to tell you we're not going to take the time to write it all, but it is in your filled-in notes. But the point of inflection is where your graph changes concavity. Most of the time, that's only going to refer to the x value, okay? What I'm going to show you now is how you can figure out the coordinates of a point of inflection. You will never do this in calculus because we got a whole way easier way to do it in calculus, okay? But for now, this will give you an idea. I know, I hope I'm like you juniors, you know, like, oh, of course, I'm going to take calculus because I'm going to know the answers to these questions. Okay. I want you to look at this graph right here. Why did I give you a highlighter? I gave you two highlighters, and if you're a pair, then each one of you have one and then swap, okay? What I want you to do, let's look at this first graph here. I want you to highlight the parts that are concave up in one color and the parts that are concave down in another color. I don't care what colors. So let's look at this first one. This graph is concave down there, correct? Now somewhere in there that thing changes from concave down to concave up, doesn't it? It's not supposed to be a line. And then what happens? Well, it changes back to concave down. Are y'all being dangerous with those highlighters? You're hurting each other. I know. Okay, and then we've got thieves. I want you to take a look at the graph that you just highlighted. Could you figure out, based on stuff that you already know, where those points of inflection are? How could you figure out where that point of inflection, and don't assume it's where I put the point I'm going to put, because I'm just ballparking it. How can you figure out the coordinates of that point of inflection? The midpoint where? Coy said it's the midpoint between the hill and the valley. That's right. So one way that you can find a point of inflection, it's the midpoint of a segment between the extrema. Oh, the midpoint, what? A maximum or a minimum. One way is if you think of a segment between the relative max and min, then half of that midpoint, that's your extreme, or that's your point of inflection. So on your paper, We're going to find that point of inflection. What are the coordinates of those extrema? I can't tell here. This is just a mess. What are the coordinates of that extrema, that max, relative max? Negative 2, 6. What are the coordinates of this one? Is it 2, 0? I don't. Okay, we're not doing per approximate. We're going to just, we'll move it around if we have to. Let's call that. Can we call that 1, negative 1? That's what we're going to call it. 1, negative 1. How do you find the midpoint? If you have to sing the song that Miss Lashley taught you. When finding the. No, that's when finding the distance between. I don't know. What's the midpoint song?
Add up the y's and divide.
That's quadratic formula. That's quadratic formula. Okay, that's slope. Okay, to find, yeah, that's distance. Midpoint, add the x's and divide by 2, add the y's and divide by 2. I know it's a song, I just don't know what it is. I thought you were doing when finding the distance. That's not it. Yeah, they're two different ones. No. So what do you get? Negative 2 plus 1? Negative 1, half of that? So that point of inflection, the x coordinate's negative 1/2. What's the y coordinate? Add them up and divide by 2. That's it. That's one of the points of inflection. Now, if you'll notice, right in there, my function changes from concave up to concave down. Let's find that point of inflection. Well, as Coy said, it's between that valley and that hill. What are the coordinates of that relative extrema, relative maximum right there? 2, 0. So what is my POI, point of inflection, there? 3/2, negative 1/2. What happened? That's one way you can find a point of inflection, halfway between relative extrema. Now, I want you to look at this last graph. And I want you to use your markers, and I want you to highlight where the graph is concave up, then different color concave down, and so on. Oh, whoops, I screwed up. Oh no, you weren't paying attention to my work, were you? Yeah. There are 3, aren't there? This graph goes from concave up to concave down and back to concave up. So there are 3 different intervals of concavity. Now, question. Go back and talk about zeros. What are the zeros of that function? Negative 2 and negative 2 and 2. What's the multiplicity of the 0 at negative 2? Why? Wait a minute. It changes concavity, doesn't it?
Yeah.
Oh my gosh, a 0 of multiplicity 3 is a point of inflection.
You say that again.
A 0 of multiplicity 3 is a point of inflection. No, it's right there. Yeah, right? So the second way you can find a point of inflection is at a 0 of multiplicity 3. Again, this is all in the filled in notes. You can copy it down later. How does what work? Right there. That is a 0 of multiplicity 3 because the graph changes concavity there. And remember, that's the definition of a point of inflection, where your graph changes concavity. Yeah. Now, does that graph have any more points of inflection? Yes. So somewhere in this neighborhood here, somewhere maybe? How are we going to find that one? The midpoint between what? It's not between two extrema. I'm going to find the midpoint of what segment? Between where and where? Between this 0 of multiplicity 3 and the next extrema. I'm going to find, this is the third way to find a point of inflection. It's the midpoint of the segment between a 0 that's got multiplicity 3 and the next relative extrema. The coordinates of that point are -2, 0. You told me the coordinates of that point were 1, -5. Find the line segment midpoint. -1/2. And what? And -5/2, right. That's your other point of inflection. Dum, da, da, dum. I think that's pretty cool. You make sure that you write down this stuff right here out of the filled in notes. Okay. We're going to skip that one for now. Let's go on. Define intervals of concavity. I'm not even exactly sure how you define intervals of concavity, except it's where the graph is concave up and where the graph is concave down. So what you're going to do you remember when we did intervals where your function was increasing or decreasing? And we just used the x values? That's what we're going to do here. Let's look at this one because we found the points of inflection on this one, didn't we? We had a point of inflection right there at -2, 0. And we had a point of inflection, was it -1/2, -5/2? I don't want to put it there. So there are 2 points of inflection. Did you get it done? Get it done? Good. All right, right there. Is that graph concave up or concave down? Concave up. So here's what we're going to say. Concave up on what interval? From where to where? -∞ to -2. Concave down Let me do it this way. On what intervals is this graph concave down? Remember the x values, where to where? -2 to -1/2. Purple. And then what? Concave up on, no, x value. Now listen, you can do this. You can write concave up once. Concave up on -infinity to -2, and then you can just put a comma, and then -1/2 to infinity. You don't have to write concave up again. You can if you want to, but you don't have to. What questions do you have at this point? Can you find a point of inflection? Okay. Let's look at this one. I want you to find the points of inflection. But first, let's decide how many of them are there. Use your highlighters and outline. Change from concave up to concave down. Do your highlighting. How many times does that graph change concavity? No. How many times does it change? It goes from concave down to concave up. So there's only one point of inflection. How are we going to find that point of inflection? Midpoint of what? Good, of the line, the midpoint of the line connecting the extrema. Midpoint of that line segment right there. What's that, 1, 4? Is that 3, 0? Did I hear 2, 2? I agree, 2, 2. That's your point of inflection. POI, 2, 2. POI, point of inflection. Now let's determine the intervals of concavity. What do we know right there? So this graph is concave down on where? -infinity to 2. And the graph is concave up on 2 to infinity. Good. Mm-hmm.
So on homework, is there anything we can repeat that, or do you want to sort it out?
No, CCD, nuh-uh. You can, no CDC, and no. You can do conc down and conc up. And that's all. I will let calculus abbreviate there as well, because the AP graders will allow that. Now, if you notice right here, golly bum, this is every darn thing, right? This is everything. Let me look. We've got one more page of notes, correct? And what? It's the same stuff, isn't it? So we're just going to work one of them. You want to work this one, or you want to work the one on the back page? Back page? All right, let's work the one on the back page. So all this is going to do, folks, is it's pulling everything together. I'm going to start right here. Domain. All real numbers. What's the range? No, range ain't all real numbers. Remember, left to right, down to up. -infinity to 6. Open, closed, half open, what do we got? 6 included, good. Zeros in their multiplicities. -5. So I'm going to do this once, twice, once. Is that okay? Let's go up here. Intervals of x values where f is positive. A function is positive when its graph, y, because the y values are positive. Where is this graph above the x-axis? What kind of interval? Open interval. Where else? Good. Intervals of x values where f is negative. A function's negative when its graph is below the x-axis because that's where y values are negative. Where does that happen? Right? 2 to infinity. Yeah, 2 to infinity. Because we're going left and right, not up and down. Left end behavior. Yep, as x approaches negative infinity, f of x approaches. Yes, because the function, as we say in calculus, decreases without bound. Decreases without bound. Right end behavior. Also, negative infinity. Because the function also decreases without bound. Good. Type of function and why? Quartic. Why is quartic? That's beautiful. The sum of all the multiplicities is 4. So it's quartic because the sum of all the multiplicities is 4. Intervals of x values where f is increasing. Where's that function increasing? Negative infinity to where? In negative infinity to -4. Increasing -2 to 1. Yep. Let's skip the decreasing. Let's go to relative maximums. Where do you have a relative max? X equal, well, we're going to give the x values. At x equals -4, is that the only one? Question, can a relative maximum be an absolute maximum? Yes, because the definition of a relative maximum is where the graph, no, changes from increasing to decreasing. From increasing to decreasing. So, changes from increasing to decreasing, changes from increasing to decreasing. So both of those are relative maximums. Do we have an absolute maximum? When x equals 1. That's where the absolute maximum is, where x equals 1. Relative minimums. Is that it? Because the definition of a relative min, where the function, good, changes from decreasing to increasing. Absolute minimum. Does not exist. Good. You can write D and E for does not exist. Go to points of inflection. Use your highlighter, outline your concavity changes. So your graph goes from concave down to concave up to concave down. How many points of inflection? 2. That's not right. I got one in this region here, and I got one in this region here. Find them. Yeah, -3, 3/2. And then what's the other one? -1/2, 3. Remember, you're just finding the midpoints between consecutive extrema. Intervals of x values where f is concave up. Where's this bad boy concave up? On what x values? X values concave up. It's going to start at a point of inflection and end at the next point of inflection. So from -3 to -1/2, that function is concave up. Can that be a closed interval? No, you do not include your points of inflection because that's where the thing changes. Intervals of f of x where f is concave down. -infinity to where? -infinity to -3. And where? -1/2 to infinity.